Hyperplane is very important concept to understand support vector machine, which is the key topic of this week. Okay, so because the 3D dimension or 4D dimension is very hard to imagine, I will use 2D space. There are two input, x1 and x2. And there is a line function, a linear function on the 2D space, R2. Okay. In this case, we can present the linear function with this equation fx, which is equal to beta 0 plus beta 1 times x1 plus beta 2 times x2 equal to 0. Okay. All x1, x2 values on this line will satisfy this condition. Beta 0 plus beta 1 x1 plus beta 2 x2. Okay. Let's say beta vector is beta 1 and beta 2. That consists of two parameters, beta 1 and beta 2. Let's say x vector is the value x1 element and x2 element. Then the function fx is equal to beta 0 plus the inner product between beta vector and x vector, and which is equal to 0 indicate the line here. Okay. Then what is the meaning of this beta vector? Okay, essentially, let's say this location is a comma b, and this location is c comma d. Okay, then this vector is a minus b, comma b minus d, right? This vector is a minus b and b minus d. And since the 2 points a comma b and c comma d on this line, they also satisfy this beta 0 plus beta 1 a plus beta 2 b is equal to 0. Beta 0 plus beta 1 c plus beta 2 d equal to 0. Oh, sorry. This is typo. A minus c, a minus c here. Okay. And let's subtract the first equation and the second equation. Then this is beta 1 times a minus c plus beta 2 times b minus d, which is equal to 0. Okay, and this is equal to inner product between beta vector and a minus c, b minus d vector, this vector. Okay, so the key point is this. Whenever you pick 2 points on this line, and when you draw a vector between the two points, then we always have the same direction. The vector always share the same direction, and the vector between 2 points and the beta vector, this beta 1 comma beta 2, always make 0 inner product value. And when 2 vector has 0 inner product value, then we say the 2 vectors are orthogonal. Okay, when two vectors are orthogonal, then the inner product between the two vectors are 0. Okay, so here the beta vector, which represent the linear function on the 2D plane, is essentially orthogonal to the function